Hi. Okay. Hi, guys. First of all, good afternoon. Thank you for coming to our talk. And in the next few minutes, we will talk about how establish Covert channel abusing or using 80 commands in GSM networks. Okay. Well, a short and brief presentation about us. I am Alfonso Munoz, Mindcreep on Twitter. I am the head of cybersecurity lab in an important cybersecurity company in Spain. And my skills are focused mainly on offensive and defensive security. And here you have more information about me. And here with me, my friend Jorge Cuadrado. Koken727 is one on Twitter, and he's a very good cybersecurity researcher, and he's focused on cloud security and pen testing. Okay. Well, here you have more information about us, and if you want to contact us, okay, here is the info. Well, this talk is a little bit strange, so we need to here are some previous concepts, okay? All our tests were realized for academic research, and up to our knowledge, no real system has been damaged, okay? Up to our knowledge. Maybe yes, but we don't know, okay? This is enough for now, okay? We continue. Well. Before explaining our results, we would like to introduce a couple of previous concepts, okay? Because we focus on ways to exchange information using Covert channel, okay? And in the base case, without paying. Vale? That point is important. For that, we want to study the freaking history. For us, is interesting because maybe it's a good starting point, okay? Sorry for that, but I need some definition, okay? And I read, but quickly. Freaking is a slang term coined to describe the activity of a culture of people who study, experiment with, or explore telecommunication systems, such as equipment and systems connected to public telephone networks, okay? Maybe you know. The term freak is a sensational spelling of the word freak with the PH from phone, and maybe also refer to the use of an audio frequency to manipulate a phone system. Freak, freakers, and phone freak are names used for and by individuals who participate in freaking. Okay? Well, the freaking history is amazing, and as attribute, we have printed some whistles we have here, for example, with our 3D printer. We have a small works, if you want, okay? And we have a big one, okay? It's true that, obviously it doesn't work, but it's funny. It's a stone, but, in the slide you have more information about this topic if you want to advance. And, there are a good reference and a good links. Okay, what is the beginning of our research? Well, with all previous information, our effort is to understand better how the mobile phone works at a low level, okay, from a computer security point of view. In fact, there are some proposal and new attacks that is interesting to know. Maybe, as you know, there are some attacks that are difficult to avoid from our mobile phone. There are some good examples. For example, SS7 attacks and attacks to the managed radio communication. Okay, some quick reminders. About SS7 attacks. SS7 is a set of protocols allowing phone networks to exchange the information needed for passing calls and text messages between each other and blah, blah, blah. Okay? What is the problem? Once they have access to the SS7 system, a hacker can easily have access to the same amount of information and snooping capabilities a security service, okay? This is a very famous and very big problem, ¿vale? Okay? Another kind of attacks is about the software that manages radio communication, and as you know, every mobile phone runs two operating systems, the one you interact with, like Android or iOS, and the one that controls the radio hardware that, you know, the second OS is so insecure, okay? So at this point, we think that it's a good idea to build our own mobile phone, okay? To have more control about what is transmitted and how it's transmitted, and maybe we can, after, create maybe covert channels, and maybe to send information, and maybe without paying, okay? So now Koke talk more about that because it's the basic for our results, okay, for the later. Oh, sorry, okay. Well, obviously, a good idea is to study what other researchers obviously have previously done in this direction, okay? Koke talked more about that, but this is a good example of this idea, this transcriptophone that maybe you know. Okay.
Well, we going to talk about mobile construction now. As Alfonso said, this was the origin of our research. We were talking about privacy, secraphony, well, this cool stuff. And we ended talking about what's the control we have in the data in our smart devices, in our smartphone, in our telephone, what's happening inside, what are the services that our device is running. At the end of the talk, we were not so sure. You know, it's like, what's happening? It's like so obscure. It's not easy to know what's happening there. So we decided to build our own phone. We decided to discover what are the main parts, how they interact with the GSM network. You know, if you want to research something, you have to start from the base. In this case, we decided also to define some objectives, okay? We decided to make an easy to recreate device. We decided to make it, and also with the objective that other people could build the same device. And with another objective, we decided that this device were also usable in the real world. We don't want some device that it's only academic. We want something that could call, that it's easy to use, you know. And also we define another objective. We decided to make it recycling. Recycling for us was like a way to make the building process more simple and also to decrease the budget of the project. In our case, if you look at this, at the left image, you can see we recycle some headset we have in our home. We recycle also a power bank. Well, it was also not only easier to make, also it fix some problems that other open hardware project has with the battery in concrete. Well, also you can see our first beta project. This mobile is even is little than a normal smartphone, but well, that's not true because this device doesn't have any battery and you have to plug into the electrical network. So, well, but we discovered only with this device that it's possible. You can make your own phone. So it was the start of all. After that, we decided to improve our phone. This is the second version. You can see in the videos how is the interface. Sorry, it's in Spanish. And you can see a simple menu. You can see the input of the PIN number. You can see there that it's a Debian cell, the thing you are looking. And also you can compare the size of the device with my smartphone. You can see that it's more or less similar size. Well, Happy news. We are release all the knowledge we have gathered about this project. All is free in GitHub. In this link, you can see the wiki of the project, which is where all the knowledge we have is recorded. Well, it's half translated to English. It's half-half. I will translate it when I have time, but shortly it will be all translated. And well, you can see there also a picture of the scheme of construction. It's so simple. As I said, we wanted to make it as simple as possible. And also you can see a case we built for our 3D printer. It's a simple one, but well, it was easier than we expected to make. So if you want to try it, I recommend you. There is some simple programs to make this kind of projects, and it's so great. And well, we will continue with now with the investigation.
Okay, with this previous information and knowledge, we talk about our research. Okay, we want to create Covert channels. Is the idea, and we want to use 80 commands. Okay, 80 commands, and in some way to send information in a GSM network. If it's possible without paying, better. If not, well, but the idea is that. Okay. So a quick definition, we try to use Covert channel, okay? As you know, a Covert channel is a type of computer security attack that creates a capability to transfer information object between processes that are not supposed to be allowed to communicate by the computer security policy, okay? We don't have time to go deeper in these principles or ideas about steganography or Covert channel, but all our project or our research is about how to create different ways of Covert channel, okay? Well, here is the more important slide in the talk, okay? What is our research? Okay, we focus on the client side. Sorry, here. And here, for example, is the emitter, and here is the receiver, okay? We will make change to the client antennas or mobile phone, for example, here or here, using 80 commands. Is the idea. We use the antenna that we already use in our handmade mobile phone. Okay, so all the knowledge is useful here. Okay, with this information, the idea is to see if it's possible with this kind of 80 commands that you apply here in these antennas, it is possible to send in some way some change through the GSM network that allows to send information to a destination antenna. Okay, so you change here using 80 commands, and in some way the network send information to the destination antenna. Okay, is the idea. And in the back, in some way, the network telecommunication create a Covert channel. Okay, all our experiments don't exploit any failure about the telecommunication companies. We use standard protocols, and we think that these kind of attacks are generic for any provider. Okay, in fact, we only focus here on the interface, network interface. Okay, more details about the specific components in our research.
Okay, as Alfonso said, we are only focusing on the interface of the GSM network. So what's an interface for us? An interface has two components, two main components. Okay, we have the GSM module, and we have the SIM card of the module. So I'm going to start with the GSM module, and later I will explain about the SIM card. This is our module. This is a SIMCOM SIM 900, and it's a usual one, not so difficult to get. And why? Why have we choose this module for our project? Well, this module can work in these bands of frequency you can see there, 850, 900, 1800, 1900. So this module should work in more or less all the world. Okay, and what we have to do to interact with this module? This module works using 80 commands that are so regular commands. It's using in many of the devices, and it's not something so strange. In this case, this module is using the 7.07 and the 7.05 and a proprietary standard of SIMCOM. Well, what can we do with these commands? We can send SMS. We can send MMS. We can use the GPRS. And, of course, we can send voice and audio. And also, we can interact with Internet. So, as you can see, this module is so flexible. We can make so many kinds of different projects. But also, it's also some forgotten characteristic in this kind of devices is also the temperature range that they can work. In this case, it's -40 degrees to +85 degrees. So also, if this module was flexible, now you can use it not only inside, you can use it in every part of the world, independent of the temperature, and you can, I don't know, use it in the mountain if you want. And, well, also so important part is the price. This module is 21 euros, and you can get it in any online store. You will get it maybe in 1 week. So I think that's also important. And here, the other part of our interface is the SIM card. Okay, if you want to call using the GSM network, you need a SIM card. We are making calls, so we are using SIM cards. And there is a fact. If you are going to make a Covert channel, you're interested in making it anonymously. You want to be anonymous. So if you want to call anonymously, you need also an anonymous SIM card. Now in Europe, it's not legal, but it's a pity, but it's also possible to get this kind of cards nowadays. For example, in the picture, you can see some anonymous SIM cards of London. Well, why are we focusing in the interface of the GSM network? Well, traditionally, companies and systems trust their security in the fact that the user can interact with the hardware. Many years ago, maybe get a BTS hardware or a GSM client was so expensive, so difficult, it was not easy to manage to get one. But we are seeing in these years that it's cheaper and cheaper and easier to get this kind of modules. So this kind of security by obscurity is now not as trustable as it was. So that's the reason, because we have started this investigation about the GSM interface, but it should work not only in the GSM interface. We think many systems trust in this kind of assertion that users can't interact with the hardware of the system. How have we managed to start our research? How have we made it? Well, there is in the corner a tweet, a screenshot of a tweet, that we think it summarizes well how we managed to do it. We have get the manual, and we have go command by command, looking if it does the thing it must do, and also if it doesn't the things it shouldn't. Here you have the first page of the documentation of our module. Well, the main part I can say is like, it's so great if you can't sleep. It was like so many great naps after reading this. So here you can see the boring part of an investigation, but it's needed. It's like, you can see notes, nodes above nodes, not below nodes. If you don't like only one color because it's ugly, you can use various colors. It's okay, but at the end you get this. It's only one slide, but this is the result of all our investigation. And in the commands, the first command you can see is the ones we are using in our demo. And the below commands, it's ones that we haven't used, but are also useful for another projects. Okay, so I will start with the ones we have used. First, we have the ATD and ATH command, which is the call command and the hang up command. We have the AT plus CLIP, which will show the metadata of a call. We have also the AT plus CLIR, which will show our metadata when we are calling or will hide it. It's a normal hidden call. And also we have the AT plus MO ring, which will say us when our call has arrived to the destination. So as you can see, only with these 4 commands, we can create a simple data flow. We can start the data flow, we can stop it. We can use the AT plus CLIR to send the data we want, and also we can be sure that the data has arrived to the destination, only with these 4 commands. And well, I will explain later a bit more about these commands, how we have used it, but I will mention also these and other commands that we haven't used because they are so interesting. The first one is to enable the error report. In our case, our errors wasn't so useful, but in another company proprietary standards, there are another errors that can be so useful. Also, the second one for me is the most fun command. With the AT plus BTS, you can create sounds using code. You can, in this case, we haven't used it because you have to establish a call. In our case, we are not establishing a call, we are only dialing. But if you want to establish a call, you can use it and you can send a huge amount of data. Also, there is the third one, which will also deal with proprietary standard metadata. And also the fourth one is so interesting because, well, we haven't used it, but we should. And with this command, you can receive, well, you can see the metadata of more than one call at the same time. So this is great also. And well, there is another 2 ones that are also really interesting. You can see the slides after the talk, but if you have any question about that later, I can explain a bit more about that. Okay. Well, here is also another page of our manual. This is, for example, you can see the ATD command, which is the command we use for a call, for start a call. And you can see also the metadata, well, the errors that this command is sending to us. We have, in the first versions of our software, we used this metadata. You can see it's 4 values, and you can, in every call, you can send 2 bits. But the problem with this command is like, we were like putting calls in a special ways to generate these commands. But the problem is, in some of them, you have to disconnect from the network, and it slows down all the process. So yeah, you can send a real message with this, but it will be so slow, so we decided to don't use it. Also, we have also the AT plus CLIP. With this command, you can send metadata. You can see the metadata of a call. So we can manage to make the calls in a special way to change that metadata. Which kind of metadata we can send with this command? You can send, okay, your mobile ID, your mobile number, the station you are connected to, and also if you are in an internal phone network, you can send also the internal ID. So this is the main command we are using to transmit information because it's clear that it's useful. And also, we have the AT plus CLIR, which is like, okay, I will show you your metadata if I activate that, or I will not show you. It's on 1 or 0. It's so easy. It's a so clear way to transmit also information. And well, here is the first demo.
Okay, here is an example of first demo. Okay, here we can see one of the possible Covert channels that we can create. Okay, on the right you can see our environment more or less to do test. Okay, you have 2 antennas, 2 Arduinos, and obviously 2 SIM cards. Okay. So at the end, we have an emitter and a receiver, okay? And here is an example of Covert channel. For example, using 80 commands here, for example, this number is fake, okay? It's not real. Using this kind of command, we can send, for example, a bit 1. At the end, we use a missed call with a hidden mobile phone number, okay? And we can send bit zeros with this specific command using missed call with visible mobile phone number, okay? So with 80 commands, we can manage a protocol, and at the end, we can send information. And if you think in this example, we send information without paying, because we don't establish any formal communication. Okay. Well, video always is better, so okay, here. Well, we can see the first demo. Well, in this demo, we send 88 bits, okay, of information. Now it's important to listen.
As you can see, in the left part we are sending the information, and well, in the right part we are receiving it.
So every 7 seconds, more or less, sounds a missed call, okay? And well, it's true that this mechanism is very stable, and obviously you can send information without establishing a formal communication, so without paying, okay? Always the same idea. And well, obviously this mechanism is slow, okay? But well, it's free, so well, it's fine.
As you can see, the receiver is receiving GOT, so we are transmitting Game of Thrones.
Yes, or not. Well, obviously, this video is 17 minutes, I don't remember. Well, okay, obviously. What is the mouse? Here, okay, go to the end. So, 17 minutes for 88 bits, okay? It's so fast. Okay. But works. Well, at the end, obviously, if you go here, you can see a message. Okay. The message is, hi hackers, hi hackers. And well, we send 88 bits, and in this specific example, we use 88 missed calls, okay? Every missed call, 1 bit. Perfect? Yes. Well, more information about this specific example, okay? We discover different ways to create Covert channels, okay? All our tests have been restricted to Spain, but we think that they work in other countries, okay, because it's generic. Well, in general, we can send more or less 12 bits per minute, okay? So the hidden capacity of our Covert channel is 12 bits per minute. A good question is if this quantity, this amount of information is enough or not. Too much or too little? Okay, well, it's true that you can send information of interest with this amount of time, okay? For example, in 3 minutes, you can send an IP address, you can send one address, one GPS coordinate, so, well, it's great. For example, 1 hour, more or less 700 bits, okay? So 700 missed call, okay? It's a lot of missed call, okay? Here, for example, you can send cryptographic password, well, a lot of information. And obviously, if you use this mechanism one day, for example, you send this amount of information that may be, I don't know, a picture, image with good resolution. Okay? Well, another good question is how stable this kind of covert channels are, okay? There are some important topics or results about that. For example, no SIM in our research has been banned in the last 5 months, okay? Every day, more or less, we send 1 hour of information, okay? More or less 700 missed calls per day, a lot of missed calls always, right? And 700 bits. And this, well, always in our experiment, we use registered prepaid SIM and anonymous prepaid SIM. The longest test was 2 days without interruption or blocking, and we decided to stop it. The feeling is that network telecommunication companies don't apply any control about that. So if you can send information, send. Maybe it's slow, but you can send, okay? Anyway, today, well, our interest now is to study amplification techniques. How, well, examples to send more information using less, for example, less missed call, okay? The idea is, well, go faster, no? is the idea, okay? So we study several amplification techniques. In the next slide, we talk more about 2 examples of amplification techniques. One is virtual phone numbers mechanisms, configuration by the internet, but working in a 2G scenario without internet, and the possibility to create covert channel using caller ID spoofing technique, that in this case we combine different mechanisms working in a 2G plus internet scenario, okay? So more detail about these amplification techniques.
Well, as Alfonso said, one of the characteristics of a covert channel is the capacity. So when we started to research that, it was like the most simple method you can imagine is like, okay, we have 1 SIM card with 1 GSM, so why not 2? And why not 4? And why not 8? If you can send 1 bit with 1, why not 8 with 8 SIM cards? So this method was like so expensive, of course, and also not so easy to configure, because at the end you are dealing with so many hardware devices, you have to synchronize them. So, but well, if you like that idea, you can see in the picture the modem pool, that it's so cool actually to use more than 1 SIM card at the same time. But the other alternative we managed to find was the virtual numbers. Well, when I started with this research, I didn't know what was that, a virtual number. What's that? A virtual number is some kind of number you can pay for, but it's but you don't have it. You can call them and you can configure the mobile number, the virtual number, to make some commands. For example, if someone called this number, redirect the call, forward the call to me, for example. Or you can do the opposite. If I call this number, please forward the call to another device. In the next demo, we are going to implement this. We have get 16 virtual numbers, and we have configured it to forward all the calls to the receiver of the call. So it's so clear to see that if, for example, I call the first virtual number, the call will be forwarded to the receiver, and the receiver will see the virtual phone number, not mine. So when the receiver gets the call, it sees, okay, this is the first one, so it's 0001, because we have 16 numbers. But that's not all. If we can get another 2 bits, for example, we can use it for a control flow. If we call directly to the receiver, we can call it normally, or we can call it hiding or ID, so the receiver will be these 2 bits. Also, another interesting fact about this is like, okay, we have a layer between the emitter and the receiver, so the emitter doesn't know what's the receiver, and at the same time, the receiver doesn't know what's the emitter if you don't use this control channel. And the important part, what's now the capacity of data? In this example, you can send 28 bits per minute using 7 calls in a minute. So we have more than duplicate the capacity of our Covert channel with another demo. And
here the next demo, okay? Well, in this demo, there is music, so enjoy. It's 3 minutes, okay? Because it's important to see in the reality. It's the same, okay? It's send information, but with a few calls, okay? Is the idea. The same environment, but in the cloud, okay, there are a lot of virtual numbers.
Do the impossible, see the invisible. Row, row, fight the power, touch the untouchable, break the unbreakable. Row, row, fight the power, power to the peaks, power for the dreams, so missing pieces.
The protocol is very simple again, so it's not.
Underground, see how easy they all fall down. Digging through the core to see the light. Let's get out of here, babe. That's the way to survive.
I remember its virtual mobile number is €1, €1 or €2. I don't remember.
not more expensive.
It's possible to get free and pay. You choose your option to do that. Well, we send this message in this case. It's 40 bits, if I remember well.
As you can see, so explain, we are using 16 virtual numbers. We are sending 4 bits in each call.
This is a real situation, okay? You need to wait. Okay, well, go. Okay. Here you have the result. We send 40 bits and we use only 10 missed calls, okay? So every missed call, 4 bytes in this specific example. So with this mechanism, we want to be less noisy, okay? It's amplification technique. And in this example, we send this specific URL, HTTP 18, and this is a Tor address that if you want to rent a hacker, okay, this is the URL to do that. Well, our last demo is about how to use some specific internet service to do this kind of amplification techniques, okay? Here we can use, for example, caller ID spoofing mechanism to create covert channels, is the idea. The idea is to use the combination of fake mobile phone number to create a covert channel, okay? Because it is possible, it's very easy to create fake mobile phone numbers. And with this idea, for example, we can send up to more or less 29 bits per missed call, okay? So one missed call, 29 bits. So it's a good amplification technique. Well, our specific demo. Well, we try to exchange a lot of information only with one missed call, okay? Only one. And for that, we use missed call, obviously. We use the fake caller ID spoofing mechanism, and the idea is the receiver will receive a call from a fake mobile phone number, and this fake mobile phone number, in some way, hide the information, okay? The hidden information is in the fake mobile phone number. So the receiver only need to decode, in some way, this fake mobile phone number and to get the hidden information, okay? So we can see here this demo, for example. For doing a quick demo, we use a short URL. For example, we choose a valid URL, but we put a fake parameter, okay? And in this parameter, we configure a lot of information. We create, for example, a short URL. Okay. Here we have the URL, and we create two scripts. The first one, you put the hidden information, in this case, the short URL, and convert to a fake mobile phone number, okay? This is a stupid algorithm here, but you have a fake mobile phone number. And in this script, you can recover the information, okay? You put the fake mobile phone number. Here is the, here is the hidden information, okay, that you send. But obviously, it's a URL you can connect, and after that, you can recover all information. In this case, well, cryptographic password, Tor address, Bitcoin address, a lot of information, and more. So the last point is how the receiver will receive the call, okay? So we can use a lot of service. For example, this is in Spanish, llamadasperdidas.com. You put the fake mobile phone number, okay? This, for example. Put the number of, for example, my mobile phone, this, okay? Well, this is a virtual number because I don't want to show my real number, okay? But it's this. and play, and that's all. The service phone call to my mobile phone, here is the number, okay? And the receiver only need to get this number, put in this script, and recover the hidden information, okay? So with only one missed call, again, without paying, we can create a covert channel, and in this case, transmitting here 20 byte bits, and here a lot of information more, okay? Well, some conclusions and future work.
Well, to summarize all, we have talked about how we have managed to create a covert channel with the most simple ways, and then we have tried to improve the capacity we can send, and finally we have mixed it with internet. So the conclusions we have here is like, this is not, we are not exploiting some vulnerability. We are not dealing with an error. It's more like about the design. We are using normal features of the network. We think it's not easy to solve this. We think the ISP should monitor strange behaviors in the use of the network, but it can be useful for the first two methods. But in the last one, it was only one call, so we are not so sure about how to fix that. Well, to finish, we have talked about a mobile phone. This is a free project, and we also want, if you want to collaborate with the project, if you want to help us to improve that and to help with this project, please contact us or make a pull request in GitHub, because we think it was the origin of our investigation, but we think it could be also the origin of another ones, and it could also help to as an educational project for other people and concern about privacy. So, well, guys, thanks for all, and thanks for coming here to hear about this.
Okay, thank you very much.
And thank you, Alfonso and George.
Some questions?
Are there any questions?
We have 3 whistles, so this is the best one. So.
Each one is okay. Oh, all right. Thanks for the talk. Great stuff. So you highlight the problem, and there is no solution, right? So there is no easy solution. So do you plan to bring, the problem you highlight to general audience? For example, there is Mobile World Congress, which is like a huge conference on mobile. It might be that these people might listen to you and might come up with some solutions, even if it's not so easy. So are you planning to work with standard organizations or with vendors or telcos to try to address the problem somehow?
Well, by now we haven't planned about that, but well, we are open to try to continue researching about that, but we really don't know because it's something about the protocol and the design of the network. So we will see.
In fact, it's a normal behavior. So yeah. In this is the sample examples, and it's only call. So.
Well, but it's your responsibility now that you have presented such a problem to try to, at least talk with the people you think might, work to find a solution.
Okay. Well, I can listen well. Okay.
Yeah, let's talk offline.
Let's talk now. Okay. No le suelo.
Thank you. I know that, you are part of group BBVA, and being like a large company in Spain, and you have a relationship, I guess, with Vodafone or Telefónica. Have you reached with them just to see if they actually care of monitoring this, or they have the capability or anything?
We in my case, we talk.
Yeah.
And no, the answer is no.
Yes, sir.
This guy, a specific guy,
yeah,
said me that no.
Okay.
And the problem is not that. The problem is, in some way, you need to block the SIM card. And the problem is when you decide that. 10 missed call, 700 maybe is a bad behavior, but 10 missed call per day?
No, yeah.
1 per day? No, obviously no.
Yeah, I imagine like,
yes.
I don't know.
So that is the problem.
2 months of transmission. Thank you.
Penco, que es que no lo suelo. No, ¿tú lo sabes? ¿Oyes?
Hey, thanks for the talk. And are you planning to add the other methods to your research? because you were just using one method and you presented different methods taken from the specification. So, or am I wrong?
Well, here we have show only the methods we have implemented for the demo. But we have more methods that it was like, okay, we can talk about them, but we think it's more interesting to show you the result of something implemented.
And do you know what is the capacity of using these other methods to transmit data in Covert channel?
There is another two more that is more or less the same capacity because they improve in some things, but the performance decrease in another thing. So it's more or less the same capacity in all.
But for example, in the last sample, in this, I don't remember, but I think it's 1,000 bytes, I think, but it's not real because here is only 29 bits, but you use a URL, and in the URLs, you can encode more information. So it depends. With only 2G calls, up to 30 bits per minute is our best result.
Okay.
But if you use a mixed scenario, a lot of information, a lot.
Thank you very much.
Any more questions?
No more?
Then give it up one more time for George and Alfonso.
Okay. Thank you very much. Thank you, guys.